For those of you guys just joining us in the video, we did just cover this forever card yesterday, handling integration with absolute value functions. Someone asked me this morning, what do I title the card? Something to do with integration and absolute value. Go team. But we're solving this example. We realized, looking for the zeros of the integrand, there were 2. So we had to do 1, 2, 3 jumps, 1, 2, 3 integrals, using absolute value on the outside, because even though you could visualize this guy pretty quickly, we can't always visualize the graphs of who's inside the absolute value. So better safe than sorry. What do? Split up the bounds, find the sums of the absolute values of the resulting definite integrals, which is what we're about to do. The kids have been playing with the numbers, and it's my turn. So plugging in -1, I got -1/3. Minus -1 will be +1. That's f of b minus f of a. -3 cubed is -27. Over 3 is -9. Minus -3 is +3. But did you guys, after the f of b minus f of a, put in your absolute values? Now pause. This is like a basic math fact, and yet it's so easy for us to confuse. Can you do subtraction inside an absolute value? Is that legal? Yeah, of course. You don't touch the absolute value. You don't let the absolute value affect anything until you get one single number. Then ask yourself, okay, did you end up being positive or did you end up being negative, okay? Super common mistake is to start like changing negatives to positives. No, that's not what absolute value does. Plugging in over here, I think I get 1/3 minus 1. That's f of b minus f of a is -1/3 plus 1. There we go. Then I have my absolute value again, plus, and then I have my 3 cubed is 27. 27 over 3 is 9 minus 3 minus f of b minus f of a, which will be 1/3, bless you, minus 1. Whew. All right, we're getting close. Looking good so far? I'm going to end up with, right here, 2/3. And I have -6, but minus +6. Which I'm going to go ahead and just go for it. Because 2/3 plus 6, 6 and 2/3, you can go that route. You can make that 18/3 plus 2 is 20/3. 20/3 stayed positive. Are we good? Okay, next one. I end up with -2/3. That's going to be a positive 2/3. So another minus the positive 2/3. I have my absolute value. Isn't that -4/3 but changed to be positive? We okay? Nice. Some of you do like the numbers. 9 minus 3 is 6. 6 minus a -2/3 is 6 plus 2/3. You guys agree? Which will be another 20/3 that stays the same. My final answer should be 44. Anybody plug it in the calculator and get something to the effect of 44/3? We're checking. We're checking. Make sure you can integrate either from the home screen or the graph. My advice would be the home screen. What'd you guys get? 14.666666? There we go. Probably somewhere the calculator goes to 7. All right, it approximated. Guess who's better, us or the calculator? This time we are. Go team. How we doing? Okay. Was it a little bit scary at the beginning? But is it impossible? Just keep it straight. And don't do the absolute values until the very end. Did you guys notice that? We can already tell what was going on in the graph. This was positive area, that was negative area that got flipped, and that was positive area. That should make sense with the graph. Now that we visualize it, remember our goal is to not have to. Here's our x squared minus 1. As soon as you put in an absolute value, keeps the positive the same, flip the negative the same. And so what we were doing between -3 and 3 is we were finding this positive area stayed the same, this positive area stayed the same, and then this negative area, we flipped the sign, and we added, done, roughly speaking. Do you know? It was me splitting up the bounds. How do we do that? We look to see what our A and B is, so I kind of think of it like the number line with Riemann sums. And then we look and see, are there any intercepts in between? Because only at intercepts can a graph go from being above to the flip. Now, At zeros, it can also bounce. Like it could have been positive, 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 and we didn't actually need to flip anything. But more often than not, if they're giving us this type of problem, there's some sort of negative that needs to be flipped. So what we do is we say, who are the intercepts? The math is just take the integrand, what's inside the absolute value, set it equal to 0. So we took x squared minus 1 equal to 0. You could do x plus 1, x minus 1, or you could just add the 1 and plus or minus square root. And then we went ahead and thought of those as being in between my original bounds. And so we made integrals from, you have to go from left to right like it showed. But we have to stop at -1, stop at 1, and then stop at 3. Does that make sense? Yeah. So the one yesterday that I did, the e to the x one, it only had 1 0 in between. We had the graph, so we went ahead and looked at it. But technically, we had the graph. So what could you have done with this guy without even needing the graph in any way, shape, or form? You could have taken this e to the x minus 1 off to the side and said, hey, who's your 0? And then when you solved, you would have e to the x equals 1. How do I get rid of an e? ln. So ln both sides, ln both sides. X is equal to, what's ln of 1? Not the derivative, the actual value. 0. I know. Remember, ln has an x-intercept at 1, 0. ln of 1 is always 0. So why did we split up at 0? Well, because on the graph we saw it was an intercept, or because it is the only 0 and it's in between the -1 to 1. Patricia. All the green is what I put in after we'd already finished solving. So originally with the red, I was like, hey guys, look, the positive can stay the same. So from 0 to 1, let's not change anything. Let's just make it a plus. But from -1 to 0, we have to flip the sign. So I had a negative that I distributed. And then after we did this and we saw the forever card, I was like, we didn't need the graph. We didn't need to know this negative. We could have just split it up at the 0 and put absolute values and been fine. But that's not how we solved it the first time. Does that make sense? Yeah. So if we had solved it, this new problem, like we did the other one the first time, we would have thought about the graph and said same, opposite, same, and then we would have forgot the absolute values and just had a positive, then a negative, and then a positive, and the negative times the negative would have worked. But the only way that works is if we know the graph. So the absolute values are kind of like our fail-safe. They're like, I don't know what's going on. I don't want to think about the graph. Let's just do the math. That rhymed. Anyway, absolute value. However, if you guys were doing homework, you didn't just see absolute values. Didn't you also see something called average value? Ooh, good reading. Average value. I don't know if I can say this is one of the most tricky topics, because it really isn't. Actually, it kind of really is. But I don't think I can call it the most tricky topic. However, it is the one that AP guys love to use to try to trick you quite a lot. And we're not going to fully be able to see that until you're in the midst of AP review. We finished all the content for the course, and then you just see the word average, and you're like, aha, I do this. And then I'm like, oh, no, poor little things. I'm sorry, you do this. So I'm not going to necessarily, partially because you'll all forget it anyway by the time we get to the AP review and need to be reminded anyway, partially because we're trying to finish this section. 36? Yeah. Gracias. I'm not going to go into tons of depth. Besides, it might be a good idea for you guys in your forever cards to make a special note of the 2 cards, the 2 formulas that involve, actually kind of the 3, that involve the word average. Not value, but average. Where have you seen the word average before? Good. Motion is one way, or just rate of change is another way. Average rate of change or average rate, or average velocity. You could have seen it with average, actually specifically saying velocity, or you could have seen it with average rate of change. One way of seeing average rate that we've talked about, and technically of f of x, you've seen f of b minus f of a all over b minus a. This is also known as the slope of a secant line. This is also known as estimating a derivative given like a table, and you have to like jump between two different x values. We had that on the motion packet, I think, somewhere. Another way that you've seen it is, all my good markers aren't up here, average velocity. And who is velocity? The rate of change of position. So we could do this one with s of or x of b minus x of a all over b minus a. You could also have things like, since we're doing position and motion, all of a sudden you could have like x of t2 minus x of t1 or t2 minus t1. You can put t's in there, whatever. You can make them s's, you can make them x's. We've seen the word average before, right? But what does this forever card say you need to find the average? An integral? An integral. I'm going to put a quick note below, and I'm not entirely sure I want you guys to put it in your forever card, but I am letting it be up to you. If they say the average, not rate, what does it say? Value. Couldn't we rewrite this to be the antiderivative of b minus the antiderivative of a by the fundamental theorem of calculus all over b minus a? Wouldn't these two be the exact same thing? The definite integral from a to b of f of x dx times 1 over b minus a is the same thing as the antiderivative of b minus the antiderivative of a all over b minus a. Wait, so it's really just an average rate? Well, kind of. Rate of who? Who's in this formula? Little f or big F? To find the average little f, it would be the exact same thing as the average rate of big F. Let me try to give you an example. If I said find the average velocity, and I give you velocity, can I plug velocity into the average velocity formula from last semester? No. This doesn't want velocities. What does this want? Positions. How do you go from velocity to position to get to our formula that we learned last semester? Integrate. Oh. So if they want the average of the thing that they gave me, the average velocity, oh, I need to go back from velocity to get to his antiderivative to use the average rate. How do you go back in integral? But it gets weirder than that. What if they say something like, hey, what's the average temperature over, and they give you a function of temperature? Do they want the rate of change, or do they want the average temperature? Yeah. So you're going to have to put it in an integral, because the only time we're allowed to use this is if we have the quantity whose average rate we're trying to find. But if they say find the average velocity given velocity, average population given population, average time given time, that's awkward, average temperature given temperature, we're going to have to plug it into the integral formula, because it's like we're not allowed to put the quantity whose average we want in a rate formula. So specifically, this one from last semester was a rate. This one is average value. Is the word average the same? Yes. Are the formulas the same? Only if you understand them properly. If you have a quantity whose average rate you're trying to find, plug it in the slope formula. If you have the quantity whose average value you need to find, plug it into the integral. So down here, I've given you position, yeah? X of t is equal to negative 2t squared plus 3t minus 1. For an example, there's my position. Then I say find the average rate of position. What's another way of saying average rate of change of position? Average, not average value, average velocity, yeah. So technically this one is saying average velocity. Find the average velocity. Position. So I can find the average velocity, or I can estimate the instantaneous velocity somewhere in between by using x of 5 minus x of 0 all over 5 minus 0. And how do I find it with position? I just plug it in. No big deal. That was last semester stuff. So plugging in 5, I end up with 25, negative 50. Negative 50 plus 15 would be negative 35. Minus 1, negative 36. And then we could put in something like, if you wanted to, let's say that this was in feet. And then time was measured in seconds. I could say feet per second. Do I have a velocity? Yes. Do I have an average velocity? Yes. But what if instead of giving you position, what if they gave you velocity? What if instead of giving you position, they gave you velocity? How do you find the average value of VO? Isn't that still average velocity? Do you guys agree? There's different ways of saying it, but the average rate of change of position is an average velocity, and the average value of velocity is an average velocity. The problem is the function's already been derived. It's giving us instantaneous values, and we need to go backwards. We need to go backwards to average it. So how do we go backwards to average it? Well, we use our average value formula. If they want the average of the thing they already gave us, okay, fine. 1 over b minus a times the integral from a to b of negative 4t plus 3. The integral will accumulate all of the different changes in positions. Well, actually, no, hold on. What does the integral do? Wouldn't we just go ahead and do a quick little antiderivative, right? You guys can have some options on this. You could just go ahead and keep that 1/5 out until the very end, and you could go ahead and plug in. Wait, isn't that negative 2 times 5 squared plus 15 f of b minus f of a? What does that end up being? 25 and 2, negative 50 plus 15. What happened? Weren't they supposed to be the same thing? Did anybody catch my mistake up here? Okay, 1 over 5 minus 0 ends up being time, ends up being seconds. The definite integral ends up being a change in position, ends up being feet. So you get feet per seconds also by doing this. But hold on, these two should match because did anybody realize my velocity was the derivative of my position? Both of these were asking the exact same question over the exact same interval with two equations that modeled the motion. What did I do quickly that I shouldn't have? Mental math. Struggle. What happens when you plug in 5? You get negative 36, but what did I never do? I never plugged in. Well, I did plug in B. I didn't plug in A because I was like, oh, 0 is 0, right? Wait, what's 0? Struggle. Okay, what's negative 36 plus 1 over 5? There's my negative 7 feet per second. Lo siento. On definite integrals, do you think every now and then you really might start hoping that anytime you plug in 0, it's 0? Yeah, be careful. Not always 0. We saw that yesterday a little bit, and we just saw it again today. When you plug in 0, not always 0. You have to actually go looking for it. But there are two different ways, guys, to find average, and in this case, average velocity. One way is to have the antiderivatives and to plug and chug to our old school formulas. But the other way is to have the actual quantity and plug into the integral. And you might be like, okay, well, this is dumb. There's two ways of doing the same thing. On the AP, remember how there are calculator portions? What kinds of functions will they give you on calculator portions? The impossible kind to solve by hand. Which means they'll give you maybe a velocity or something similar, a population, a temperature, and etc. that you cannot solve by hand the antiderivative. You're going to have to use your calculator to do this formula. Average value, forever number 36. So what's the last forever card? We have one more minute, unless everything's a minute behind like yesterday. What's the last forever card? FTC Part 2. FTC Part 2 says, what do I do if I'm supposed to be taking the derivative of a definite integral? What am I supposed to be doing if I'm supposed to be taking the derivative of a definite integral? Forever number 37 and the final one of Chapter 4a. Whew, lots of forevers, which is why the quiz is not tomorrow. The forever quiz isn't until Friday. So you guys can get your forever cards up to date. Be studying, be memorizing. A lot of them you should already know because we've been using them over and over again. But what do we do if we're taking a derivative of an integral? Wait, an integral is a derivative backwards. What's the derivative of an antiderivative? It just ends up being itself. This is just going to end up being f of x, but this one's going to be f of x squared times 2x. Whoa, what's the difference? I thought you just cross off and plug in. You cross off and you plug in the variable if it's an x. But if it's a u, if it's an x squared, if it's a 5x, if it's a x minus 1, you plug in the u, but what else do you have to put? U prime. And maybe we'll look at tomorrow as we're going over homework questions as to why the u prime is there. But for right now, according to this forever card, and as soon as you guys have it down, the derivative of any constant, -1 to x, or 0 to x, or 17 to x, I don't care. Any constant to x, plug in the x, and then you can think of it as x prime, which is 1, or plug in the u, and u prime, whoever he is. All right, cool kids, homework, due tomorrow. Chapel day, and I think, right, why is no one moving? Oh, what is wrong with me? I was in a totally different period. I was in period 2. How am I in period 2 right now, guys? I was giving honors pre-cal kids pre-cal homework. This is a rough week. Praise the Lord God Almighty, we're not done. So what do I want to do? Let me show you why. You guys could have totally just walked out of here and I would have been like, what? Let me show you why. You ready? Good. I was wondering how I lost so much of class. I'm like, I don't get it. I thought we had time. Why? Did you guys see me use the forever card, though? Okay. Why? I'm going to go ahead and do full screen because some of you guys are still writing the forever card. And we do have time. Yay, so I'll stop stressing you all out. Why? Guys, fundamental theorem of calculus says any definite integral is the antiderivative. And what notation do I use for the antiderivative? If little f is inside, who's my antiderivative? Big F. Couldn't I make this big F of x minus big F of a, even if I don't know who he actually is? Just notation-wise, couldn't I change the definite integral to be antiderivative of the top bound minus antiderivative of the bottom bound? Do you guys agree? For any definite integral they give me, with any function in between or inside, I can always say, okay, well, whoever you are, your antiderivative of b minus your antiderivative of a, and the x is in the b spot, a is in the a spot. That's what would result, even if I don't know how to find you by hand. Now, kiddos, if you go to take the derivative of f, whatever, if you go to take the derivative of, wait a minute, I shouldn't say equals, I should say minus, but guys, who's the derivative of antiderivative of a? Wouldn't it be f prime of a times a prime? What rule did I just use? Wait, which? I'm actually not using FTC quite yet. I'm just taking a derivative, and the derivative of this guy is his prime, minus the derivative of this guy. What rule did I do right here? Derivative of the outside, keep the inside, times derivative of the inside. Chain rule. Who's A? I said, did anybody catch it? He can be any, not A. Hold on, we've been using A's, we've been using B's, they've been giving us C's, every now and then we see K's. What are all of those guys always indicating? Constants. Okay, good, 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 good. If you need to, maybe make yourself a note if you don't know that A is a constant. A is a constant. Any constant. Arbitrary constant. I don't care. Anybody. So what's A prime going to be? No, 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 no. A is constant. What's A prime going to be? 0. You'd be plugging in 17 to the antiderivative. It'll be a number. You'd be plugging in 0 to the derivative. It'd be a number. You'd be plugging in -1 to the antiderivative. It'd be a number. Whoever this guy is, you'd be plugging him in and you'd be getting a number. And what's the derivative of any number? Wait, no, that doesn't matter. Oh, what's the antiderivative's derivative? The original dude. Oh, that's why. The antiderivative's derivative is the original dude. It's the integrand. So how did this guy come about? Well, let's say we were to take the antiderivative. Let's say we knew who he was. It'd be f of the top bound minus off f of the bottom bound. Antiderivative of the top bound minus antiderivative of the bottom bound. If you were to take the derivative of whoever the antiderivative is, I don't care. Take the derivative, though. What rule am I going to have to use again? Chain rule. So I'm going to have capital F prime of x squared, times u prime. Whatever the antiderivative is, I would have to take his derivative, but also not forget my u prime. And what's going to happen again when I go take the derivative of the antiderivative with or at any constant? 0. Do you see where this guy came from? Who is the antiderivative's derivative? Back to the beginning. But what else do you have to include? U prime. Now, that was super general because I didn't give you an integrand. I didn't give you an actual function inside the integral, and I didn't even solve for antiderivatives because I didn't know who the original guy was. But what if I was to give you this guy? Probably directions similar to part of homework if you guys kept kind of pushing through. I've heard homework is long. But should be pretty straightforward, I think. It's not quite like motion where you have to kind of like be second guessing all of your life decisions every single problem, right? I'm just kidding. You don't do that, do you? Should be pretty straightforward with rules and such, right? But let's go ahead and see what's going on here. Number 6 says, hey, we're going to call this guy by a name. And you're like, a capital F? I don't get it. Okay. They're just calling him by a name. Whatever. They're going to do them whether or not we like it. So, okay, fine. That's capital, sure. All right. His name is capital F. Go team. What does letter A say to do? Find? Okay. And who's this guy? That guy. All right, fine. I'm going to find the derivative by taking the derivative. And what I do to one side, I have to do to? All right, if they want me to find prime, all right, fine, I'll prime, whatever. I'll go up, I'll prime him. They could call it G, they could call it H, they could call it P, they could call it capital T, I don't know. But they want his prime. All right, cool, fine. The derivative of F is F prime. This isn't necessarily talking about an antiderivative. It's just the guy's name. They decided to call him capital F and confuse you thoroughly. All right, fine. But how do I find him? Well, guys, what did we just talk about? That you can always do when given any derivative of any definite integral from a constant to a variable of a function. What does my FTC Part 2 tell you to do? Dun, 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 dun. What? Pause. Compare. The integral from a to x of any f of t dt, when derived, will always be f of x, aka the inside guy with who plugged in? X. Wait a minute, what about u prime? Well, what is your u's prime? Okay, no big deal. But, no, you're not taking the derivative of him. He's just being rewritten. Whatever f is still f. Your top bound, your variable, gets plugged in, and then if your variable has a prime, then you have to multiply by him. Now letter B says go ahead and check it by doing it. Doing what? Oh, doing the long drawn out way? Here's the sad thing. I'm going to show you a little peek behind the curtain for how to do the chain rule backwards. It's the only way to integrate this guy by hand. First integrating, then differentiating. So this one says, you know what? You should take this guy, which is the definite integral from pi over 4 to x of cosine of 2t dt. Actually find who that is and then derive, which isn't always possible, which is the point of FTC Part 2. But they're saying it's possible. I'm going to help you along with how it's possible. Then we'll take the derivative and see if it matches what is above. So, zoop, 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 zoop. You guys at least see that the antiderivative of cosine of 2t has something to do with the sign, right? Okay. Can anybody tell why I'm going to put a 1/2 when taking my antiderivative? Why did I put a 1/2? What's the derivative of sine of 2t? Cosine 2t times u prime, right? It's been a while since we took derivatives of f of u's. Isn't the derivative of sine of u cosine of u times u prime? So isn't the derivative of sine of 2t cosine of 2t times 2? But what's not there? A 2. So what did I have to have waiting for my 2? Ah, so now the derivative would be cosine of 2t times 2 times 1/2. The 2's cancel, haha. Okay, don't worry, there's a whole process. We'll talk about it in chapter 4b. But for right now, just believe me, that's the antiderivative, okay? Wouldn't we then have to go ahead and plug in b and plug in a? So 1/2 sine of 2, plug in who? X, minus 1/2 sine of, what's 2 times pi over 4? Isn't that pi over 2? If that is my f of x, then how would I find my f prime? Take the derivative. Okay, cool. 1/2 times cosine of 2x times u prime minus, some of you are already thinking about, oh, hey, pi over 2, it's here, and then my sine is 1, and you're totally right, the sine is 1, but 1/2 times 1 is 1/2. Pause! It's all a what? Constant whose derivative is 0. Who cares? It's all a constant whose derivative is 0. Hey, guys, how did my FTC Part 2 do? Not too bad, huh? And who's easier? This one or that one? That one, but what do you got to know? Your forever card number 37. No, there's more? Wait, so don't do it the long way. Do it the short way. What's the short way say? As long as I have an A and I have a U, as long as I have an A and I have a U, my formula says, oh, hey, isn't this just f of u times u prime? So who's your f of u? E to the 2 times x squared, but what else do I need? Who's u prime? Sweet. Final answer is 2x e to the 2x squared, and I didn't have to antiderive. Nobody. But the only time you can use this really cool theorem is when you have a derivative and an integral, a derivative and an antiderivative. They're inverses of each other, but in a special way. They're inverses of each other. Oh, she's gone today. I'm giving that back to you, Tete ASB. Lo siento. So what would you guys do in letter B to use FTC Part 2? What? Is AJ right? How'd she say negative? Why'd she say negative? Look at your theorem. Is it x to a or a to x? Ooh, it's in the wrong order. But what did we learn from properties of integrals, definite integrals? What can we do? Rewrite it. We can flip it as long as we make it negative. So, can we still take a derivative? Sure. Can we still use the theorem? Sure. We just had to rewrite it first. So what does your theorem say? Oh, well, there's a negative. Sure, why not? And then it's going to be f of x times x prime, or f of u times u prime. So plug it in. Isn't it just negative and then x squared times 1? Does that make sense? Does this theorem take a little bit of work? A little bit of getting used to. A little bit of getting used to as to who is u and how you do the u prime and how you plug it into the actual variable itself in the t spot. But other than that, it's really not that bad. Oh, how did I get off? Oh, because we added a forever card for absolute value, and I thought we were done. Lo siento, guys. There's one last one. Forever 38. I just need to get you guys the formula. With MVT, you guys remember there was a formula we plugged in, f prime of c. If I had realized how much we had left, I would have known class didn't get out at 9:30. F prime of c is equal to f of b minus f of a all over b minus a. This one is just a variation where we can say f of c is equal to 1 over b minus a times the integral a to b of f of x dx. And that might look weird to you, except ultimately, there's two different ways of writing it. Sorry, I'm just doing the other variation. Ultimately, if you think about it, with capital F prime, this would be the same thing as capital F prime of c is equal to antiderivative of b minus antiderivative of a all over b minus a. It is a variation on the original MVT, where the original MVT had antiderivatives, and so the new MVT is using the integrand, or the integral. Kiddos, that's where homework should end. You have your formula that you can use. It's literally a plug and chug for A's and B's and trying to find C's that meet. I think, wasn't 37 the last forever card? Isn't this 38? Yeah, because this one's 37. Average value. All right, cool kids, we're done. Sorry, we're good. You just needed to get that last formula so you can use it whenever the book says MVT for integrals.